Hello, I'd like to talk about pressure, which is a Year 7 topic. So let's have a look at what pressure might be. Okay, if you hold a pencil horizontally between each palm of your hands and you just push gently on the other end of the pencil with your arms have got equal strength. So without pressing too hard and hurting yourself, how does each end feel? Which end feels different to the other depends on the size of the end. And obviously the blunt end will feel fine, but the sharp pointy end, if you push too hard, will start to feel a little bit painful. But why do they feel different? Why does the area make a difference? Does the force make a difference, or is it the same force in both arms? So that's what we're going to be looking at today when we're looking at pressure. All right, so we're going to describe what pressure is. We're going to explain pressure in terms of the force and the surface area that force is being focused on. And there's a formula or an equation for pressure, which we're going to have a look at using too. Right, and why pressure? So pressure is vital in physics. It's vital to understand how things happen in everyday life as well, from the caterpillar tracks on a big digger, the wheels on a tractor, to the tip of a needle or a hypodermic syringe. And pressure is a fundamental part of physics. It applies throughout to solids, to liquids, and to gases. So you can feel it everywhere you are in the atmosphere, underwater, and against solids. And it's vital to many jobs and roles as well. So being an engineer, a scuba diver, a nurse when you're giving injections, a builder when you're making sure that the pressure is sufficient to hold things together, and a weather forecast looking at atmospheric pressure and trying to work out what the weather might be in the future. So thinking about the picture you can see here, you've got a balloon being pushed down with some force on a bed of nails. Now, if it was just one nail, the balloon would burst quite easily with very little force being pushed down onto it. But here you can see the balloon is being squashed, so there is quite a lot of force on the balloon, but over a bed of nails, over dozens of sharp points, it doesn't burst. And that is because if you look at the key words I want you to be thinking about, the surface area of one nail is tiny, but when you've got the surface area of lots of nails added together, that surface area becomes almost equivalent to having a flat surface. And if you push the balloon on the equivalent of a flat surface, then the balloon is unlikely to burst. So there's a big force being pushed down on the balloon, but there's a big surface area as well. So we're talking about this ratio between force and surface area, and this is leading us on to what pressure is. And you can see in this picture that some people even take this to the extremes of lying on a bed of nails, but as you can see, she seems quite comfortable. There is a big surface area with all the heads of the nails added together. It's almost equivalent to lying on a carpet or a flat floor. All right, so we've talked about force and area. How can a finger push a drawing pin into a wall, but not your finger itself? Well, the drawing pin has got a very, very sharp point. So all of the force of your finger, your arm, pushing against the pin is focused on a very, very small point. And that small point experiences what we call a big pressure. And that big pressure is what pushes the pin into the wall. Now, if I try to push my finger into the wall, my arm has got the same strength, but obviously my finger has got a blunt end to it compared to the pin, and it doesn't have the same surface area. So same force, but a bigger surface area is going to be a lot less pressure, and therefore it's very difficult, if not impossible, to push your finger into a wall. All right, so we're talking now then about this ratio between force and surface area. And we can see this when we're banging a hammer into a piece of, banging a nail, sorry, with a hammer into a piece of wood. So again, the force of the hammer would be the same whether the nail was upside down or pointing down, but it's the sharp point we're going to drive into the wood, because again, that's going to really focus that force of the hammer onto a very, very small surface area. And it's that optimum combination of a big force and a small surface area that's going to give us the greatest pressure. So what is pressure then? So it's a ratio of force, which is measured in newtons, and surface area, which is measured in meters squared. And when you combine those two together, you can either talk about pressure in terms of newtons per square meter, or you can talk about it in terms of pascals. And those units are named after Newton and Pascal, you can see below. So explaining the above then in terms of pressure. So you've got huge, great big diggers which operate off-road. They are very, very heavy, and in muddy conditions, the only thing that stops them from sinking is the fact that their caterpillar tracks are going to provide them with a big surface area to spread their weight and to reduce their pressure. Don't forget, weight is a type of force. So you've got this enormous force pushing down over this big surface area, and this is going to give the pressure quite a low value, and therefore caterpillar tracks will stop the tanks or the tractors or the diggers from sinking into the earth. Where you have a car, which is a lot lighter than a digger or a tank, They've only got the 4 tyres, very small surface area where the tyres are actually touching the surface of the road or the field, and therefore if the field is quite soft, it's very quick and easy for a car to have that small force but a very small area pushing down into the mud and sinking. And in the next picture, you can see that we have a lady wearing high heels or stilettos, and she's cracking the tiles because although she's probably just an average human weight, the force of her body, the weight of her body, is being focused on those incredibly small heels that she's wearing, and therefore the pressure is sufficient to start cracking tiles. Whereas if you walk with great big snowshoes on, like 2 tennis rackets strapped to your feet, you can see you're spreading your weight over a much bigger surface area, and even on a very soft and squishy surface like snow, you're not going to sink in. You're going to be able to walk without going up to your knees in snow and getting all your trousers and your clothes wet and cold. So it's all about this ratio of force to area. And if we think about it, if you've got a big force and a small area, then you're going to have a big pressure. But if you've got a big surface area and a small force, then you're only going to get a small pressure. So we've got these 3 variables. We've got pressure, we've got force, and we have got surface area. And in physics, you can often play with the variables and arrange them into a formula or an equation so that you can start to calculate them and start to put quantities as to what those variables are. And this is the pressure equation. So you can see that pressure equals force over area, which is equivalent to saying pressure equals force divided by area. And remember, force is measured in newtons, area is measured in meters squared. So pressure is newtons per square meter or meters squared. And the other unit we can use, the equivalent one, don't forget, is pascals. Right, let's have a look at an example then of how to calculate pressure. So a box weighs 100 newtons and it has a base area of 2 meters squared. So to calculate the pressure, we need to apply our FIFA principles. So the first thing is the F for formula or equation. And we've just seen that. That's going to be pressure equals force divided by area. So we write the equation, the formula first every time. Then we can move on to I. So we're going to insert the values that we have in the question. So we've got 100 for force, we've got 2 for the area. So we're going to have the pressure equals force divided by area equals 100 newtons divided by 2 meters squared. If we need to fine tune it, if we need to think about the units or rearrange it, then this is the time to do it, but we don't need to do it for this one, so we can progress straight to the answer. And it's physics, not math, so there's always got to be units as well. So 100 divided by 2, we're going to get the pressure is 50 newtons per square meter or 50 pascals. It's as simple as that. Okay, and just to have a couple of practice calculations to consolidate those, if you were to have an elephant stand on you, you could calculate the pressure by looking at the figures we have for the elephant weighing 40,000 newtons and 1 foot has an area of about 0.1 meters squared, whereas if a girl weighing 400 newtons, 100 times lighter, was standing on your foot with a high heel, which is a much, much smaller area of 0.0001 meters squared, you can calculate the 2 pressures and work out which one would hurt the most. If you want to just pause the video and try and apply the equation and those FIFA principles and try and work out what the 2 pressures are, and then we can check your answers moving on to the next slide. So we can see that for the elephant, again applying FIFA principles, the formula pressure equals force divided by area, inserting the values that you can see, calculates an answer of 400,000 newtons per square meter, or equivalently 400,000 pascals. And for the high heel, then again the same procedure, the same method. We've got 400 this time divided by 0.0001, and that gives you 4 million pascals. So even though the woman's or the girl's weight is 100 times less than the elephant, because her force is focused on a much, much smaller area, the pressure will be 10 times greater than the elephant standing on your foot. So that is pressure then. It's all about this ratio of force to surface area, and it can be thought of as an equation or a formula where you've got pressure equals force divided by area.